Peer-to-peer computing or networking is a distributed application architecture that partitions tasks or workloads between peers. Peers are equally privileged, equipotent participants in the application. They are said to form a peer-to-peer network of nodes. Peers make a portion of their resources, such as processing power, disk storage or network bandwidth, directly available to other network participants, without the need for central coordination by servers or stable hosts. Peers are both suppliers and consumers of resources, in contrast to the traditional client-to-server model in which the consumption and supply of resources is divided. Emerging collaborative P2p systems are going beyond the era of peers doing similar things while sharing resources, and are looking for diverse peers that can bring in unique resources and capabilities to a virtual community, thereby empowering it to engage in greater tasks beyond those that can be accomplished by individual peers, yet that are beneficial to all the peers. The first P2p distributed system platform was Pipe's platform by PeerLogic. One of PeerLogic's first licensees was Texas Instruments in 1993. While P2p systems were used in many application domains, the architecture was popularized by the file-sharing system Napster, originally released in 1999. The concept has inspired new structures and philosophies in many areas of human interaction. In such social contexts, peer-to-peerism refers to the egalitarian social networking that has emerged throughout society, enabled by Internet technologies in general. Historical development: while P2p systems had previously been used in many application domains, the concept was popularized by file-sharing systems such as the music-sharing application Napster. The peer-to-peer movement allowed millions of Internet users to connect directly, forming groups and collaborating to become user-created search engines, virtual supercomputers, and file systems. The basic concept of peer-to-peer computing was envisioned in earlier software systems and networking discussions, reaching back to principles stated in the first request for comments, RFC1. Tim Berners-Lee's vision for the World Wide Web was close to a P2p network in that it assumed each user of the web would be an active editor and contributor, creating and linking content to form an interlinked web of links. The early Internet was more open than present day, where two machines connected to the Internet could send packets to each other without firewalls and other security measures. This contrasts to the broadcasting-like structure of the web as it has developed over the years. The idea of peer-to-peer began in the 1960s, when Arpanet was created as a network to share files between U.S. research facilities, and every host was seen as equal, none more important than the others. As a precursor to the Internet, Arpanet was a successful client-server network where every participating node could request and serve content. However, Arpanet was not self-organized and it lacked the ability to provide any means for context or content-based routing beyond a simply unregistered trademark address-based routing. Therefore, a distributed messaging system that is often likened as an early peer-to-peer architecture was established, Usenet. Usenet was developed in 1979 and is a system that enforces a decentralized model of control. The basic model is a client-server model from the user or client perspective that offers a self-organizing approach to newsgroup servers. However, news servers communicate with one another as peers to propagate Usenet news articles over the entire group of network servers. The same consideration applies to SMTP email in the sense that the core email relaying network of mail transfer agents has a peer-to-peer character, while the periphery of email clients and their direct connections is strictly a client-to-server relationship. In May 1999, with millions more people on the Internet, Sean Fanning introduced the music and file-sharing application called Napster. Napster was the beginning of peer-to-peer networks, as we know them today, where participating users establish a virtual network, entirely independent from the physical network, without having to obey any administrative authorities or restrictions. Applications: peer-to-peer networks underlie numerous applications. A common application is file sharing, which popularized the technology. Communications: instant messaging systems and online chat networks. Other P2p applications: Bitcoin and alternatives such as Peercoin are peer-to-peer based digital currencies. The U.S. Department of Defense is conducting research on P2p networks as part of its modern network warfare strategy. In May 2003, Anthony Tether, then director of DARPA, testified that the U.S. military uses P2p networks. Wireless Community Network, Netsukoku, Dailies a peer-to-peer web cache for LANs. Open Garden, connection sharing application that shares Internet access with other devices using Wi-Fi or Bluetooth. Research like the Cord Project, the PAS storage utility, the P-Grid, and the CoopNet content distribution system. JXTA, Currency Fair is a peer-to-peer foreign currency exchange marketplace. Content delivery. Indiana, P2p, networks, clients both provide and use resources. This means that unlike client-server systems, the content-serving capacity of peer-to-peer networks can actually increase as more users begin to access the content. This property is one of the major advantages of using P2p networks because it makes the setup and running costs very small for the original content distributor. File sharing networks. Many peer-to-peer file sharing networks, such as Gnutella, G2, and the eDonkey network popularized peer-to-peer technologies. From 2004 on, such networks form the largest contributor of network traffic on the Internet. Peer-to-peer content delivery networks. C. Contiki, Ignite, RedSwoosh. Peer-to-peer content services, for example caches for improved performance such as Corelli caches, software publication and distribution. Via file sharing networks. Streaming media, P2p TV and PDTP. Applications include TourPlayer, Juiced, Cool Streaming, Cyberski TV, PPLIVE, LiveStation, Giraffic and Idiom. Spotify uses a peer-to-peer network along with streaming servers to stream music to its desktop music player. Peercasting for multicasting streams. See Peercast, iShare, FreeCast, Rawflow. Pennsylvania State University, MIT and Simon Fraser University are carrying on a project called LionShare designed for facilitating file sharing among educational institutions globally. Osiris allows its users to create anonymous and autonomous web portals distributed via P2p network. Intellectual property law and illegal sharing. Peer-to-peer networking involves data transfer from one user to another without using an intermediate server. Companies developing P2p applications have been involved in numerous legal cases, primarily in the United States, primarily over issues surrounding copyright law. Two major cases are Grokster vs. RIAA and MGM Studios, Incorporated v. Grokster, Limited. In both of the cases the file-sharing technology was ruled to be legal as long as the developers had no ability to prevent the sharing of the copyrighted material. Architecture. A peer-to-peer network is designed around the notion of equal peer nodes simultaneously functioning as both clients and servers to the other nodes on the network. This model of network arrangement differs from the client-to-server model where communication is usually to and from a central server. A typical example of a file transfer that uses the client-server model is the file transfer protocol service in which the client and server programs are distinct, the clients initiate the transfer, and the servers satisfy these requests. Routing and resource discovery. Peer-to-peer networks generally implement some form of virtual overlay network on top of the physical network topology, where the nodes in the overlay form a subset of the nodes in the physical network. Data is still exchanged directly over the underlying TCP/IP network, but at the application layer peers are able to communicate with each other directly, via the logical overlay links. Overlays are used for indexing and peer discovery, and make the P2p system independent from the physical network topology. Based on how the nodes are linked to each other within the overlay network, and how resources are indexed and located, we can classify networks as unstructured or structured. Unstructured networks. Unstructured peer-to-peer networks do not impose a particular structure on the overlay network by design, but rather are formed by nodes that randomly form connections to each other. Because there is no structure globally imposed upon them, Unstructured networks are easy to build and allow for localized optimizations to different regions of the overlay. Also, because the role of all peers in the network is the same, unstructured networks are highly robust in the face of high rates of churn, that is, when large numbers of peers are frequently joining and leaving the network. However, the primary limitations of unstructured networks also arise from this lack of structure. In particular, when a peer wants to find a desired piece of data in the network, the search query must be flooded through the network to find as many peers as possible that share the data. Flooding causes a very high amount of signaling traffic in the network, uses more CPU memory, and does not ensure that search queries will always be resolved. Furthermore, since there is no correlation between a peer and the content managed by it, there is no guarantee that flooding will find a peer that is the desired data. Popular content is likely to be available at several peers, and any peer searching for it is likely to find the same thing. But if a peer is looking for red data shared by only a few other peers, then it is highly unlikely that search will be successful. Structured networks. In structured peer-to-peer networks, the overlay is organized into a specific topology, and the protocol ensures that any node can efficiently search the network for a file resource, even if the resource is extremely rare. The most common type of structured P2p networks implement a distributed hash table, in which a variant of consistent hashing is used to assign ownership of each file to a particular peer. This enables peers to search for resources on the network using a hash table, that is, pairs are stored in the DHT, and any participating node can efficiently retrieve the value associated with a given key. However, in order to route traffic efficiently through the network, nodes in a structured overlay must maintain lists of neighbors that satisfy specific criteria. This makes them less robust in networks with a high rate of churn. More recent evaluation of P2p resource discovery solutions under real workloads have pointed out several issues in DHT-based solutions, such as high cost of advertising discovering resources and static and dynamic load imbalance. Notable distributed networks that use DHTs include BitTorrent's distributed tracker, the CAD network, the Storm botnet, Yasi, and the Coral Content Distribution Network. Some prominent research projects include the Cord project, Kademlia, Parse Storage Utility, pgrid, a self-organized and emerging overlay network, and CoopNet Content Distribution System. DHT-based networks have also been widely utilized for accomplishing efficient resource discovery for grid computing systems, as it aids in resource management and scheduling of applications. Hybrid models. Hybrid models are a combination of peer-to-peer and client-server models. A common hybrid model is to have a central server that helps peers find each other. Spotify is an example of a hybrid model. There are a variety of hybrid models, all of which make trade-offs between the centralized functionality provided by a structured server-client network and the node equality afforded by the pure peer-to-peer unstructured networks. Currently, hybrid models have better performance than either pure unstructured networks or pure structured networks because certain functions, such as searching, do require a centralized functionality but benefit from the decentralized aggregation of nodes provided by unstructured networks. Security and trust. Peer-to-peer systems pose unique challenges from a computer security perspective. Like any other form of software, P2p applications can contain vulnerabilities. What makes this particularly dangerous for P2p software, however, is that peer-to-peer applications act as servers as well as clients, meaning that they can be more vulnerable to remote exploits. Routing attacks. Also, since each node plays a role in routing traffic through the network, malicious users can perform a variety of routing attacks, or denial-of-service attacks. Examples of common routing attacks include incorrect lookup routing, whereby malicious nodes deliberately forward requests incorrectly or return false results, incorrect routing updates, where malicious nodes corrupt the routing tables of neighboring nodes by sending them false information, and incorrect routing network partition, where when new nodes are joining they bootstrap via a malicious node, which places the new node in a partition of the network that is populated by other malicious nodes. Corrupted data and malware. The prevalence of malware varies between different peer-to-peer protocols. Studies analyzing the spread of malware on P2p networks found, for example, that 63% of the answered download requests on the LimeWire network contained some form of malware, whereas only 3% of the content on OpenFT contained malware. In both cases, the top 3 most common types of malware accounted for the large majority of cases. Another study analyzing traffic on the Kazaa network found that 15% of the 500,000 file sample taken were infected by one or more of the 365 different computer viruses that were tested for. Corrupted data can also be distributed on P2p networks by modifying files that are already being shared on the network. For example, on the FastTrack network, the RIAA managed to introduce fake chunks into downloads and downloaded files. Files infected with the RIAA virus were unusable afterwards and contained malicious code. The RIAA is also known to have uploaded fake music and movies to P2p networks in order to deter illegal file sharing. Consequently, the P2p networks of today have seen an enormous increase of their security and file verification mechanisms. Modern hashing, chunk verification and different encryption methods have made most networks resistant to almost any type of attack, even when major parts of the respective network have been replaced by faked or non-functional hosts, creating more resilient and scalable computer networks. The decentralized nature of P2p networks increases robustness because it removes the single point of failure that can be inherent in a client-server-based system. As nodes arrive and demand on the system increases, the total capacity of the system also increases, and the likelihood of failure decreases. If one peer on the network fails to function properly, the whole network is not compromised or damaged. In contrast, in a typical client-to-server architecture, clients share only their demands with the system, but not their resources. In this case, as more clients join the system, fewer resources are available to serve each client, and if the central server fails, the entire network is taken down. Distributed storage and search. There are both advantages and disadvantages in P2p networks related to the topic of data backup, recovery, and availability. In a centralized network, the system administrators are the only forces controlling the availability of files being shared. If the administrators decide to no longer distribute a file, they simply have to remove it from their servers, and it will no longer be available to users. Along with leaving the users powerless and deciding what is distributed throughout the community, this makes the entire system vulnerable to threats and requests from the government and other large forces. For example, YouTube has been pressured by the RIAA, MPAA, and entertainment industry to filter out copyrighted content. Although server-client networks are able to monitor and manage content availability, they can have more stability in the availability of the content they choose to host. A client should not have trouble accessing obscure content that is being shared on a stable centralized network. P2p networks, however, are more unreliable in sharing unpopular files because sharing files in a P2p network requires that at least one node in the network has the requested data, and that node must be able to connect to the node requesting the data. This requirement is occasionally hard to meet because users may delete or stop sharing data at any point. In this sense, the community of users in a P2p network is completely responsible for deciding what content is available. Unpopular files will eventually disappear and become unavailable as more people stop sharing them. Popular files, however, will be highly and easily distributed. Popular files on a P2p network actually have more stability and availability than files on central networks. In a centralized network, a simple loss of connection between the server and clients is enough to cause a failure, but in P2p networks the connections between every node must be lost in order to cause a data sharing failure. In a centralized system, the administrators are responsible for all data recovery and backups, while in P2p systems, each node requires its own backup system. Because of the lack of central authority in P2p networks, forces such as the recording industry, RIAA, MPAA, and the government are unable to delete or stop the sharing of content on P2p systems. In addition to data storage, P2p systems also provide the ability to provide distributed search engines to locate resources shared on a network. Examples include Yasi, a free distributed search engine, built on principles of peer-to-peer networks. FAROO, another distributed search engine. The ScienceNet P2p search engine. Social implications. Incentivizing resource sharing and cooperation. Cooperation among a community of participants is key to the continued success of P2p systems aimed at casual human users. These reach their full potential only when large numbers of nodes contribute resources. But in current practice, P2p networks often contain large numbers of users who utilize resources shared by other nodes, but who do not share anything themselves. Freeloading can have a profound impact on the network and in some cases can cause the community to collapse. In these types of networks, users have natural disincentives to cooperate because cooperation consumes their own resources and may degrade their own performance. Studying the social attributes of P2p networks is challenging due to large populations of turnover, asymmetry of interest and zero-cost identity. A variety of incentive mechanisms have been implemented to encourage or even force nodes to contribute resources. Some researchers have explored the benefits of enabling virtual communities to self-organize and introduce incentives for resource sharing and cooperation, arguing that the social aspect missing from today's P2p systems should be seen both as a goal and a means for self-organized virtual communities to be built and fostered. Ongoing research efforts for designing effective incentive mechanisms in P2p systems, based on principles from game theory, are beginning to take on a more psychological and information processing direction. Privacy anonymity. Some peer-to-peer networks place a heavy emphasis on privacy and anonymity, that is, ensuring that the contents of communications are hidden from eavesdroppers, and that the identities locations of the participants are concealed. Public key cryptography can be used to provide encryption, data validation, authorization, and authentication for data messages. Onion routing and other mixed network protocols can be used to provide anonymity. Economic considerations, political implications, intellectual property law and illegal sharing. Although peer-to-peer networks can be used for legitimate purposes, rights holders have targeted peer-to-peer over the involvement with sharing copyrighted material. Peer-to-peer networking involves data transferred from one user to another without using an intermediate server. Companies developing P2p applications have been involved in numerous legal cases, primarily in the United States, primarily over issues surrounding copyright law. Two major cases are Grokster vs. RIAA and MGM Studios, Incorporated v. Grokster, Limited. In both of the cases, the file-sharing technology was ruled to be legal as long as the developers had no ability to prevent the sharing of the copyrighted material. To establish criminal liability for the copyright infringement on peer-to-peer systems, the government must prove that the defendant infringed a copyright for the purpose of a personal financial gain or advantage. Fair use exceptions allow limited use of copyrighted material to be downloaded without acquiring permission from the rights holders. These documents are usually news reporting or under the lines of research and scholarly work. Controversies have developed over the concern of illegitimate use of peer-to-peer networks regarding public safety and national security. When a file is downloaded through a peer-to-peer network, it is impossible to know who created the file or what users are connected to the network at a given time. Trustworthiness of sources is a potential security threat that can be seen with peer-to-peer systems. Network neutrality. Peer-to-peer applications present one of the core issues in the network neutrality controversy. Internet service providers have been known to throttle P2p file sharing traffic due to its high bandwidth usage. Compared to web browsing, email or many other uses of the Internet, where data is only transferred in short intervals and relative small quantities, P2p file sharing often consists of relatively heavy bandwidth usage due to ongoing file transfers and swarm network coordination packets. In October 2007, Comcast, one of the largest broadband Internet providers in the USA, started blocking P2p applications such as BitTorrent. Their rationale was that P2p is mostly used to share illegal content, and their infrastructure is not designed for continuous, high-bandwidth traffic. Critics point out that P2p networking has legitimate legal uses, and that this is another way that large providers are trying to control use and content on the Internet, and direct people towards a client-server-based application architecture. The client-server model provides financial barriers to entry to small publishers and individuals, and can be less efficient for sharing large files. As a reaction to this bandwidth throttling, several P2p applications started implementing protocol obfuscation, such as the BitTorrent protocol encryption. Techniques for achieving protocol obfuscation involves removing otherwise easily identifiable properties of protocols, such as deterministic byte sequences and packet sizes, by making the data look as if it were random. The ISP's solution to the high bandwidth is P2p caching, where an ISP stores the part of files most accessed by P2p clients in order to save access to the Internet. Current researchers are currently using computer simulations to aid in understanding and evaluating the complex behaviors of individuals within the network. Networking research often relies on simulation in order to test and evaluate new ideas. An important requirement of this process is that results must be reproducible so that other researchers can replicate, validate, and extend existing work. If the research cannot be reproduced, then the opportunity for further research is hindered. Even though new simulators continue to be released, the research community tends towards only a handful of open-source simulators. The demand for features in simulators, as shown by our criteria and survey, is high. Therefore, the community should work together to get these features in open-source software. This would reduce the need for custom simulators, and hence increase repeatability and reputability of experiments. See also: Client QA client, decentralized computing, friend-to-friend, list of P2p protocols, segmented downloading, semantic P2p networks, sharing economy, wireless ad hoc network, USB dead drop, references. External links.